back to the maths lecture. Okay, last time we were studying pairs of straight line, correct? So last time we have done exercise 4.2. The last exercise which is there is excluded from the syllabus for this year. Okay? So this thing you have to keep in mind. There is no general solution exercise. Okay? So whatever we have done in the lecture, that much only you have to study. One or two questions from the exercise I have excluded, that is an exercise for you. You have to complete it at home. Okay? Those are the easy questions. Now, today we are going to study with the trigonometric functions. Now, many of you have a phobia of trigonometric functions, so students no need to worry. Okay? We will be definitely working with the basics of trigonometry that you have learned in 10th standard. Okay? I'll be revising all those things and then we will move on to the exercise questions. So first of all, one important thing that I want to tell you is you should know the values of sine, cos, tan, cot, sec and cosec. Whatever we have in a table that we have learned in 10th standard, that is sine 30, sine 45, sine 60, sine 90, blah blah blah. Okay. So basically that table is important. So I want you to revise that table today. Okay. After that, the concept which you have learned in 11th standard, that I will revise here. Allied angle table. The concept is allied angle table. Now, what is the meaning of allied angle table? We are just moving from one quadrant to another quadrant. Basically, we are working on the theta. The rotation of a trigonometric function with respect to 90 degree, with respect to 180 degree, with respect to 270 degree, and with respect to 360 degree. That we are going to first study, and then we will go on the actual exercise. Right? So, we all know that there are basically four quadrants in a Cartesian plane. Correct? We call this as x-axis, y-axis. There are four quadrants. This is my first quadrant, this is my second quadrant, this is my third quadrant, and this is my fourth quadrant. Do everyone agree with this? Okay. Now after this, we all have learned that there are few trigonometric functions which are positive in the respective quadrants. Correct? So how to remember that? So I have a row that says add sugar to coffee. This you have to remember. To remember the signs of trigonometric functions. Add means it indicates all trigonometric functions. Sugar means sine, and what is the reciprocal of sine? That is cosec. Correct? T represents tan. Reciprocal of tan is cot. Okay? Cos and sec. Okay? So if you observe, this will be there in the first quadrant, this will be there in the second quadrant, this will be there in the third quadrant, and this will be there in the fourth quadrant. Okay? So here all trigonometric functions are positive. Here only sine and cosec are positive. Third quadrant, tan and cot. Fourth quadrant is cos and sec. Okay? Now I hope everyone followed this, the signs of the trigonometric functions. Now very important. Somewhere long back, you all have studied that sine of 90 minus theta is cos theta. In 10th standard, remember, also in 11th standard you all have learned this. But along with this, more little bit advanced thing you have learned. Cos of 90 minus theta. So that is sin theta. So a simple trick to construct allied angle table I will give you today. Okay, a simple trick. Now, this is our x-axis, this is our y-axis. any trigonometric function, if you convert any trigonometric function with respect to x-axis, okay, the sign, that is positive or negative, for that trigonometric function only changes. Okay. Now, what is the meaning of changing the trigonometric function with respect to x-axis? Now, x-axis has positive x-axis and negative x-axis, correct? So this measures to be 0 degree, this measures to be 90 degree, this measures to be 180 degree, and this measures to be 270 degree. Again, when we come back to the x-axis, it is 360 degree. Correct? Do everyone agree with this? Okay. So we have 0, 90, 180, 270 and 360. Let's convert it into radian. These measures are in degree, correct? So 0, this will be pi by 2, this will be pi, this will be 3 pi by 2, and this will be 2 pi. Okay, these are radian measures. Okay, we all have learned how to convert degree into radians in very first chapter of 11th standard, angle and its measurement. So how do we convert degree into its radian? Suppose we have 30 degree. Okay, we have to convert it into radian. So multiply it by pi by 1 degree. Okay, so what do we get? Pi by 6 radian. Clear? So these are the few things that I have revised. Now after this, we have to play with the trigonometric functions. Now what is the meaning of working on x-axis? Basically, x-axis has two measures, that is 360 degree, sorry, three measures, 360 degree, 0 degree and 180 degree. So we will rarely use 0 degree because it lies in first quadrant, correct? Means first quadrant has to deal with 0 degree. So when we add something to 0 degree, it will be a normal figure, that is 30, 45, 90 or something between them. So now, let me give you an example of this. One example each, okay, for x-axis and for y-axis both. So if I take sine of 180 minus theta, theta is some value, some number, okay. So I am talking that, I am saying that 180 minus theta. So if this whole thing is 180 degree and if I am subtracting something from it, so it will definitely reduce and come into the third quadrant. Correct? Correct? Now here sign, this sign. Check if this sign is positive or negative here. It is positive. Correct? So here we will use a positive value for sign because it is sign only. And 180 minus theta will be sine of theta. This is the formula which you have learned in 11th standard. Allied angle table. Go back and have a look on that. Okay, the same values you will be getting. Now, if the same thing we do with 180 plus theta, what will happen? Now, this sign will come to the third quadrant. Okay, means 180 plus theta means definitely it will come to the third quadrant. And in third quadrant only tan and cot are positive. We don't have sine positive, so it will be minus of sine theta. Getting what I wanted to tell you, that whenever we work on x-axis, only the sign of trigonometric function changes. That is, it changes from plus to minus, minus to plus, depending on the quadrant. Okay. Now, after that, one more example for y-axis. Sine of 90 minus theta is, and sine of 90 plus theta. Now we all know if we do 90 minus theta, it will go into the first quadrant, and in first quadrant all the trigonometric functions are positive. So here it will be positive, but I told you on y-axis that trigonometric function changes. So sine will get changed to cos theta. Okay. This should be sine of 90 plus theta. So sine of 90 plus theta this will lie in the second quadrant, again sign is positive. But here also the trigonometric function changes to cos theta. I hope everyone is getting what I am telling with respect to the x-axis and y-axis. See, this was with respect to x-axis and this was with respect to y-axis. This conversion I have done. Okay? This is 180 conversion, this is 90 conversion. So whenever I work on x-axis, this trigonometric function is same as that of the output. Only this sign is changing depending on the quadrant. Okay? Now here, with respect to the y-axis, this trigonometric itself is changing to the another one along with the sign depending on the quadrant. Clear? Clear to everyone? Okay. Now, this was the basic thing that I was supposed to tell you. Now let us come back to the properties of trigonometric functions or the qualities of trigonometric functions. Okay. Now let's say we have x-axis and y-axis. Let's say theta is 30 degree. Okay. So we all know value of sine 30 is half. Correct? Now what I will do, I will rotate it once. Okay? I have rotated it once. So the angle will be 360 plus 30. That is 390 degree. Correct? So if you see again, value of sine 390 degree is again half. Isn't it? Even if I rotate it n number of times and if I come to the same position, the value of sine, whatever the angle is, the value will be half only. So we all know this property of trigonometric function that after n number of rotations, the trigonometric function gives the same value. Therefore, they are called periodic functions. After a period, they repeat the same values. Okay? Understood what is the meaning of periodic function? After a certain period, means after following certain area, the trigonometric function repeats the same answer or same value. Such functions means all the trigonometric functions are periodic functions. Okay. So therefore, there are two types of solutions for trigonometric functions that are defined. First one is principal solution. First one is principal solution. And the second one is the general solution. Principal solution and general solution. Now, before going to principal solution and general solution, we will talk about what is the meaning of trigonometric equation and what is the meaning of trigonometric solution for that trigonometric equation. Okay. So, any equation that you have learned in previous classes, that is x square plus 2xy plus y square equal to 0. This is one of the equation, right? Whenever we have equal sign along with the variables, then we call it as equations. Suppose if I write only this much part, x square plus 2y, this is not an equation. This is an expression. This is an expression. But if I put equal sign into it and set it equal to something, then this is known as equation. Okay. So now we have to talk about trigonometric equations. So whenever an equation contains a trigonometric terms, let's call it as 3x plus tan x equal to 0. This contains a trigonometric function. Yes, it is a trigonometric equation. Let's say tan of y equal to half. Yes, it is an equation and it contains a trigonometric function, so it will be trigonometric equation. What about sine theta equal to 3 by 2? Yes, it is a trigonometric equation because it contains equal sign as well as a trigonometric function. So it is a trigonometric equations. Now finding out the solution of trigonometric equation means finding out the value of variable. Now what is the variable over here? Theta. We don't know the value of theta. So theta we will be finding out. So value of theta will be the solution for this trigonometric equation. Value of y will be the solution for this trigonometric equation. So basically finding out unknowns means we are finding out the solution of the given equation. Okay. So basically what happens is depending on periodicity of trigonometric functions, okay, there are two types of solutions. One is principal solution and another one is general solution. So in the syllabus for this year, the general solution is excluded. We don't have general solution in that. Okay. Now we will be learning only about the principal solution. What is the meaning of principal solution of trigonometric equation? There are now the solution, that is principal solution, will not exceed more than one rotation. Okay, it will contain only one rotation in the four quadrants. In those four quadrants, whatever solution we will get up to 360, not equal to 360, less than 360, those will be the principal solutions of our trigonometric functions. Okay, so basically a principal solution is a solution which is greater than equal 0 and less than 360. This is the one thing we have to keep in mind. This is the condition for principal solution. Okay. Now to find principal solution, we have to recall the thing which trigonometric function is positive or negative in the respective quadrant. So let's take an example based on this principal solution. That is exercise 3.1. Exercise 3.1. Find the principal solution of the following equation. And the equation is given as cos theta is half. It's very easy. Because we all know what is the value of theta when we have cos the value as half. It is 60. This we everyone know. But here there is a little bit tricky question. Basically, we always have two principal solution, not one. Two principal solution depending on the in a range of 0 to 2 pi. That is 0 to 360. Okay. Let me explain you this. Now, in a Cartesian plane here all trigonometric functions are positive. Here sine and cos, here tan and cot, here cos and sec. Okay. Now check out on the right hand side. What is the sign of this constant? It is positive, correct? Means we have to look up for the positive values. So for what value of theta or in which quadrant do we have value of cos as positive? So I also know that it is first quadrant and it is the last quadrant, it is fourth quadrant. There will be two values in the Cartesian plane, that is the first quadrant and the fourth quadrant, correct? So a base value we all know that since cos of 60, that is pi by 3, is half, and yes, pi by 3 lies between 0 and 2 pi. That is 2 pi means pi means 180 into 2, that is 360. So yes, therefore pi by 3 is a principal solution. But along with this, there is one more solution we have to find out with the help of allied angles. Therefore, by allied angles, okay, We all know that cos of. Now, what I have to do with respect to x-axis? With respect to x-axis, we know that the trigonometric function doesn't change, correct? So I have to keep constant cos only. So that will be possible when I do the transition with respect to x-axis. But what is the measure of this x-axis? This is 360 degree, correct? 360 degree, or you can say 2 pi, isn't it? And I have to enter into the fourth quadrant. So what I can do is, I know cos of 2 pi minus theta will give me cos of theta. This is my allied angle properties. Okay. Now, cos of 2 pi minus base theta we all know, that is pi by 3. This is equals to cos of pi by 3. And what is the answer for cos pi by 3? Is half. Correct. So therefore, cos of 3 2s are 6, 6 minus 1, that is 5 pi by 3 is equals to half. Now we have to check the condition whether 5 pi by 3 lies between 0 and 2 pi. So if we divide 5 by 3, what do we get? 1 point something, which is actually smaller than 2. Correct? Means 5 pi by 3 will be smaller than 2 pi. And 0 less than equal to 5 pi by 3 is less than 2 pi. Therefore, 5 pi by 3 is also a principal solution. Okay, therefore we can conclude this. Therefore, the principal solutions are pi by 3 and 5 pi by 3. Okay, I hope everyone understood how to find out the principal solution. Okay, in next class we will see more questions based on principal solution. See you class. Thank you so much.